Hi, my name is Mohammed Ayanafi. Today I'm going to explain the understanding process in memory. The first part is Introduction to Process in Memory. What is process? A process represents an instance of a program in execution. It encapsulates the program's code, data, and resources needed for execution. Think of a process as a living, breathing program that's actively doing something on your computer. Number two, importance of processes. Processes are the fundamental building blocks of modern operating systems. They enable the execution of multiple programs concurrently, allowing user to multitask and efficiently utilize system resources. Each process enjoys its own isolated environment, preventing interference from other programs. Process management. The operating system's process management component manages the creation, scheduling, termination of process. It ensures that process share resources fairly and prevents conflicts between them, guaranteeing system stability and efficient utilization. Basic process structure. This covers the basic concept and structure of a process in memory. Process control block (PCB). The PCB is a data structure that contains essential information about a process, including its process ID, PID, state running, waiting, etc. Memory address space and resources. Think of it as the process identity card that the operating system uses to manage it. Process memory storage. Each process has its own dedicated memory space, isolated from other processes to prevent interference. This space is divided into different sections, each serving a specific purpose. Process state. A process goes through various states during its lifetime, including newly created, ready, waiting to be executed, running, currently being executed, waiting for an event, and terminated, completed execution. The process state determines the process current activity. Part 2. Sections of a process in memory. Command line arguments. When you run a program, you might supply arguments like input files or parameters on the command line. These arguments are stored in a dedicated section of a memory so the program can access them during execution. Text section. This section stores the program's executable code, including instructions that the CPU execute. It's like the program's blueprint containing the steps of the computer follows to perform its task. Data section. The data section contains global and static variables used by program. These variables persist throughout the program's execution and are accessible from anywhere in the code. They hold data that the program works with. Sections of a process in memory. Stack section. The stack is used for managing local variables, function calls, and return addresses. Think of it as a pile of plates, where the most recently added plate is at the top and the oldest place is at the bottom. When a function is called, its local variables are placed on the stack. When the function returns, its variables are removed from the stack. Heap section. The heap is used for dynamic memory allocation. This means that the program can request and release memory as needed during execution. For example, if a program needs to store a large amount of data, it can allocate memory from the heap to accommodate it. The heap is more flexible space compared to the stack. Program counter and register status. Program counter. The program counter (PC) is a register within the CPU that holds the memory address of the next instruction to be executed. Think of it as a pointer that indicates the current location in the program's code. It moves forward as the CPU executes each instruction. Register status. The register status section stores the values of the CPU's register. These registers are small, high-speed memory location with the CPU used for holding temporary data during program execution. They are crucial for efficient computation. Demonstration with the program. So it's like hash include stdio.h int main int argument c char steric argument v int array int pointer int into pointer is equals to array. Code to fill array and use pointer. Return 0. Using command line arguments, the main function receives two arguments, argument C and argument V. Argument C represents the number of arguments passed, including the program name itself. Argument V is an array of strings, where each element contains one command line argument. These programs can use these arguments to customize its behavior or access input data. Filling the array. Direct assignment. The program can directly assign values to each element of the array using a loop. This method is suitable when the values are known beforehand. User input. The program can prompt the user to enter values for each element of the array. This method provides flexibility and allows the user to specify the array's content at runtime. Transforming the program into process. Command line arguments stores in command line arguments passed to the program. Text section contains the program's code, including the main function and any other functions. Data section holds the global variable array declared outside the main function. Stack section used to store local variables like pointer function, call information, and return addresses. Heap section not used in the simple program but could be used for dynamically allocating memory if needed. Thank you.